Okay, modulation modes, bandwidths of various signals. Which of the following is a form of amplitude modulation? And I should put the distractors in here for that. The correct answer is single sideband. Now, the amplitude modulation that we saw there in the video was double sideband, full carrier amplitude modulation. And when you do that, you have the carrier here, and it generates a lower sideband and an upper sideband. Okay? So you have the carrier, you have lower sideband, upper sideband. This is an amplitude modulated signal. This line represents change in frequency. This represents signal power. Okay?
Mm-hmm.
Now, if we depict that in this other way, we have the same thing. We have the carrier there. We have the lower sideband here. We have the upper sideband here. Please notice that the lower sideband and the upper sideband are symmetrical with each other. Okay? They contain the same information. Where's my cursor? There it is. They contain the same information as you move away from the carrier. And you can see here we have this line, and then this line, and then this line, and this line. It's a mirror image on the other side. This line, this line, this line, and this line. The two sidebands contain exactly the same information. Okay? So, question is, if we have a limited amount of transmitter power, why do we want to transmit both sidebands? Because they contain the same information. Okay? So, you know, why do it? Okay? The other question is, the carrier doesn't contain any information. So why do we want to transmit the carrier? Well, we don't, because it's a waste of transmitter power. So what we do in single sideband is we filter off one sideband. This is gone now. You see here we have only the upper sideband, and we take out the carrier. So in a single sideband signal, you're transmitting only the sideband. And all of your transmitter power can be used to transmit that sideband, which makes the maximum effective use of your transmitter power. The other important thing that it does on crowded bands is it cuts your bandwidth in half. Look here. Before we needed that much bandwidth to transmit that signal. Now we don't need only this much bandwidth, okay, to transmit the signal. So it is a form of amplitude modulation, single sideband. Okay, any questions on that? Okay, but that's what we're talking. When you hear someone talking about single sideband, that's what they're talking about. Okay, what type of modulation is most commonly used for VHF packet radio transmissions? You remember that packet was that digital type that we used with the terminal node controller, and we most commonly use FM modulation to transmit packet radio transmissions. Which type of voice modulation is most often used for long distance or weak signal contacts on the VHF and UHF bands? We use single sideband for that. Which type of modulation is most commonly used for VHF and UHF voice repeaters? Frequency modulation, or FM, is used for that. And your first radios will probably be VHF or UHF FM radios. Okay. Which of the following types of emission has the narrowest bandwidth? CW, which you'll remember is Morse code. With CW, we're just turning the carrier off and on. We're putting the information on the carrier by turning the carrier off and on, and that produces the narrowest bandwidth that will transmit information. Okay, so CW, which you'll remember means Morse code, and has the narrowest bandwidth. Which sideband is normally used for 10-meter 10-meter HF, VHF, and UHF single sideband communications? We most commonly use the upper sideband for those frequencies. Okay, so for 10 meters and VHF and UHF, we most commonly use upper sideband. What's the primary advantage of a single sideband over FM for voice transmissions? Single sideband signals have a narrower bandwidth. They have a narrower bandwidth. What's the approximate bandwidth of a single sideband voice signal? It's approximately 3 kilohertz, approximately 3,000 hertz. Okay. Any questions on that slide?
Yeah, Milt, I got a question.
Yeah.
Okay, so is the reason that Morse code is the narrowest bandwidth, or I should say, for one, you're basically turning the carrier signal on and off?
That's correct, yeah.
That's amplitude modulation, turning it on
It
and
is.
off? Okay.
Yes, it could be considered amplitude modulation. The key to bandwidth is how much information you're transmitting. Okay. To just turn the carrier off and on, you're sending information at a low rate, and so you don't need much bandwidth for it. As you increase the rate of the information that you're transmitting, the rate of the modulation, you need more and more bandwidth. So voice requires much more bandwidth than just the on and off keying. If you send pictures, that requires a tremendous amount more bandwidth because there is so much more information in the picture than there is in just a voice signal. Okay, so that's the key to bandwidth is how much information it is you're sending. And the slower you're sending your information, the narrower your bandwidth will be. Okay?
All right.
That makes sense?
Yeah.
Now, it doesn't seem correct intuitively that turning your carrier on and off would create a bandwidth, but it actually does, a very narrow bandwidth, but it does create a bandwidth, turning your carrier on and off. Okay, any others on this slide? Okay, let's move on then. Okay, what's the approximate bandwidth of a VHF repeater FM phone signal? It's between 5 and 15 kilohertz. The approximate bandwidth of the FM phone signal between 5 and 15 kilohertz. What's the typical bandwidth of an analog fast scan TV transmission on the 70 centimeter band? Okay, now remember I was saying that the amount of information you transmit increases the bandwidth. Take a look here. Here we have voice at 5 kilohertz bandwidth. Here we're sending pictures. In fact, we're sending 30 pictures per second with fast scan television. We're using 6 megahertz of bandwidth. Okay? So we're using 1,000 times as much bandwidth to transmit that picture as we are here for the voice. Okay? Typical bandwidth of analog fast scan TV transmissions on the 70 centimeter band, about 6 megahertz. What's the approximate maximum bandwidth required to transmit a CW signal? About 150 hertz is all.